Alright, so here we have a 6 kilogram object that's compressing a spring 0.45 meters. A says to calculate the energy it has when the spring is compressed. Now when the spring is compressed, we have a very particular kind of energy called potential elastic, and that is equal to 1/2 kx squared, where k is the spring constant in newtons per meter, and x is the distance it's being compressed. Alright, so what we end up with is 1/2, and our k is 30. And our x is 0.45, and that is being squared. And when we plug that into our calculator, we get 1/2 times 30 times 0.45 squared. And that is, we'll say 3 joules. Alright, so what kind of energy does the object have when released? Well, when it's released, it's no longer potential elastic, it's converted into another type of energy. And since it's moving, that energy is going to be kinetic energy. And if there is no friction on the surface, how much energy does the object, or does the mass have after released? Well, if there's no friction, we have no negative work being done on this system taking the energy out. So we get to keep all of this energy. So we have 3 joules before and 3 joules of kinetic energy afterwards. And the last question wants us to calculate the velocity of the object afterwards. Well, afterwards we have kinetic energy, which is equal to 1/2 mass velocity squared. And we know our kinetic energy is 3. 1/2 of our mass, which is 6. And then velocity squared. Well, 1/2 of 6 is actually 3. So we get 3 equals 3v squared. We can divide both sides by 3. And they actually cancel out. We get 1 on the left-hand side equals v squared. And we have to take the square root of both of those in order to get velocity. So our velocity is actually 1 meter per second.